This video is a demonstration of an example Canada Post system provided to Process Model. In this video, you will see the example model developed for Canada Post, how to experiment with the model and the associated output, and how models are assembled with Process Model. A simulation is a statistical model in the computer representing the real system. This model visually shows positions on the conveyor, the green boxes, placing parcels on the conveyor, red Canada Post logo, waiting for conveyor position, the graphic turns purple. The reworked loop uses a rate of reject to randomly select a percentage. On-screen variables can show any KPI, in this case calculating parts per hour and parts per person per hour. You can add as many as you like. Times, speeds, rates, and efficiency all can be included in the model. A simple interface can be used to show allowed changes on a single page. This was done in Excel with a supplied Process Model sheet. No programming is necessary. People not trained in Process Model can try different ideas and see the effect, isolating the details of the model from inadvertent changes. Changes made on this page can affect many parts of the model. For example, one time change here can affect 50 changes here. The interface took 6 minutes to create and link into the model. Most people in error use averages to plan systems. Using an average processing time of 2.8 seconds, pph of 1285, defines the following behavior. See how parcels neatly fit into the conveyor slots at the same time? That would never happen in a real system because people don't work at the same pace. We should change the processing time to include variability. This is a triangular distribution. It allows you to specify the shortest, most likely, and longest time for processing. Each time a parcel is worked on, a time would be picked from the distribution per the probability. Notice how the parcels are more realistically placed on the conveyor. Using variability is critical to understanding system behavior and problems. The output has many built-in reports. Graphs show the stations that are blocked. In this model, I used a variable to decide which conveyor to place the parcel. The statistic shows as waiting because it's waiting on the variable. All graphical information is also presented in a tabular form. Resource utilization is averaged. You could present it by individual if you wanted. Variables can be defined for anything. In this model, I calculated the pph and the ppph using variables. Models make system planning more effective. In less than 30 seconds, I can make a change to the model, run it, and see the effect. This allows me to fail fast so that I can ultimately succeed in finding the best solution. Conveyors are assembled using building blocks. What follows is a short video from a training post. In this video, you've seen the example model developed for Canada Post, how to experiment with a model and the associated output, and how models are assembled with Process Model. If you have further questions, please don't hesitate to give me a call.